All right, good afternoon. My name is Rob Winch, and I am the project lead for Spring Security. And today we're going to be talking about Spring Security 5, the reactive bits. So before we get started, I'd like to get just a show of hands. Who here has used Spring Framework before? Good. All right, who here has used Spring Security before? All right, good. Who here has used Spring Boot before? Awesome. Who here has used Spring WebFlux before? Okay. Who here has used Project Reactor before? Okay. And who here has done any reactive programming? All right, good. Good show of hands. All right, so that gives me an idea where you guys are at. We're going to be moving pretty quickly. So if you have any questions, I want to make sure that you guys ask as soon as you have it, because I want to make sure we're on the same page from start to finish. Okay? And with that said, a lot of you said that you've done some reactive programming. And therefore, you probably know when you should be doing reactive programming. One of the reasons that you might be doing reactive programming is if you have a reactive stack. So for example, if you have a blocking dependency like JPA or JDBC, it might not be a good fit. But I'd like to kind of take a step back and look at that a little bit more to think about when you might have a blocking dependency and when that might make sense, particularly in security circumstances. So let's think about LDAP. Who here authenticates against LDAP? Pretty good show of hands. All right, good. So who here thinks that if they went up to their boss and said, hey, I'm trying to do reactive programming, let's get rid of LDAP? Would your boss just laugh at you, or would they say good luck? Yeah, probably good luck, right? And so this is kind of what I think the story would be across the board. Now, unfortunately, LDAP doesn't have a reactive binding for it. So that means you're going to have to convince your boss to get rid of LDAP, or you're going to have to figure out something different. Well, I'm here to tell you you can do something different. There's a number of things. Well, if you have a blocking dependency, you can offload it onto another thread. Now, the difference is that you don't want to do this too frequently, right? If you're doing it for every request, then you're starting to lose some of the benefits of reactive programming. But if you're doing it with the idea that I'm only going to do it once I authenticate, and then I will cache that result in a session, for example, and then that is reactive for the rest of the requests, then you're going to be in fine shape. You know, it doesn't have to be everything. And you might say, well, that still feels a little bit funny, and I'm just doing password authentication. So I'm in the clear. I don't really have to worry about it. But there's other situations, particularly in security, that are going to cause some confusion, or at least should inspire some thoughts. So who here thinks that validating a password is a blocking operation? All right, we got a few hands. So to talk about this, we need to go through kind of the storage of password history and how passwords have evolved throughout time. And it used to be that when you validated a password, you just store it in a data store and just put it in plain text, and no one would think twice about it. And the reason for this was they justify it saying, oh, OK, well, if I put it in a data store and it has a username and password, it's secure because no one can access it. But then they realized that that wasn't necessarily true, because people would use things like SQL injection attacks or social engineering, and they get these big dumps of passwords. And what they realized is the same username and password was being used for Mr. Nobody's site and Bank of America, or whatever banking. And so if any site gets compromised, all the sites get compromised for the passwords. And so we realized we needed to do more. So the next step that we decided to do was we said, OK, rather than storing the password, let's run it through a hash function first. What we'll do is we'll take the password, run it through a hash, and we'll store that hash in the database. And then if it gets compromised, all they have is a hash. And the hash is a one-way function. It's not meant to go forwards and backwards like encryption, decryption. It's different. It's a hash function. Kind of like a hash map. You create a key ID. You might have a collision, but hopefully not. So you produce this hash, and you put it in the database or in the data store. And then when the user needs to be validated, they give you the password that they provide, and you run it through the same hash function. If the hashes are equal, then the user is authenticated. And this worked pretty well for a while, but we realized that while it was costly at the time to crack a single password, What if we just did the work one time and saved the work, right? You basically do every password and start storing a lookup table of hash to password, hash to password. This is known as a rainbow table. You guys are probably familiar with this. Rainbow tables allowed you to look up the username based upon the hash. So what we introduced was salt. It's random bytes that get concatenated with the password, and you send both of them through the hash, and then the hash is stored in the data store along with the salt in plain text. And then when the user needed to be validated, you provide the user provided their password, use the same salt, concatenate it, send it through the hash function, and validate it, right? So now we're fine. No, it's not the end of the story, because we realize today that resources on computers have grown significantly, and we can perform on the order of billions of hashes a second. So it doesn't matter if you can't store all these password salt combinations in a lookup table. You can just do it for every password. It's not that costly anymore. And so what we've finally evolved to is, rather using a cryptographic hash that's intentionally quick, like SHA-256, for example, we now use one-way adaptive functions. And one-way adaptive functions are intentionally computer resource intensive. And in fact, they are targeted. You want to target them to be about a half a second to a second to validate the password based upon your CPU resources. And some of them actually also utilize quite a bit of memory to block against things like GPU-style attacks. But there are different types of resources. CPU is one of them that it's going to consume, and it's going to basically block operation for a half a second to a second. So with that in mind, going back to our question that we asked earlier, is validating a password a blocking operation? And the answer is, if you're doing passwords correctly, yes, it is. It is going to be a blocking operation. And you say, oh, well, now I can't validate against passwords either. Again, you can, but we need to put it into context. How often are you going to be doing that? Hopefully, you're going to take a long-term credential like a username and password and exchange it for a short-term credential like a session ID. And I know lots of people say, session, ooh, that doesn't make me feel too good about myself because it's stateful. Ooh, right? Stateful. But in security, state is good. And as long as you offload the state onto another service, representational state transfer, you transfer that state to something like Redis, store the session in Redis or some other data store, you're going to be just fine. It's going to scale just fine. You're not going to have problems necessarily. Obviously, you can abuse the session, but you can do that with any sort of data store. So the idea is basically limit the amount of blocking operations you're going to do. But in some applications, and when you're doing security, you probably are going to be doing some blocking operations. All right, so now we've gotten that out of the way. And I'm going to go ahead and switch to my last slide so we can get this out of the way also. If you guys are interested in other aspects of security, we have next generation OAuth support with Joe Granja. And then we also have cloud native platform, Cloud Foundry UAA as an identity gateway. That's a little bit of a tongue twister. But that's on Thursday at 11:50. So that's the end of my slides. And we can all leave now, or should we just do some live coding instead? OK, hopefully you like to see some live coding. We're going to start with a demo application. And this whole presentation going forward is going to be live coding and demo. And if you have any questions, again, ask along the way. We're going to be moving fairly quickly. So I have a simple application. It stores messages, and we have an inbox. And we can go ahead and view what's in the inbox, and we can go ahead and delete something from the inbox. We also have the ability to sign up a user. And then we also have a REST endpoint. And you can see that the new user is added down there at the bottom. So this is the gist of the application. There's not really a lot to it, but it'll allow us to explore some of the functionality in Spring Security's reactive support. Obviously, this application is written in Spring Webflux. And now we're going to go ahead and see how we can add Spring Security to it. So this is a Spring Boot app, as we alluded to when we were talking about our what parts of Spring you've used. I just added Spring Security Boot Starter, and I also added the Spring Security Test Jar. And you might say, well, I'm not using Spring Boot. Hopefully you are, because it's 2017. But if you're not, it's just an aggregator. It's just a set of dependencies. And you might also ask yourself, why is it Spring Boot Starter Security and not something with Reactive in it? And the reason for that is because Spring Boot already knows it's a reactive application, and the reactive support is optional dependencies in Spring Security's WebJar. So since we've already added Spring WebFlex to the project, it already knows it's going to be a reactive application and already knows how to wire it up. And you might have noticed in the keynote, Madura was saying that Spring Boot has evolved on how the security support works. All it's basically doing as soon as you add that dependency is it's adding an enable WebFlex security annotation. And we'll explore that a little bit later, but it's not really doing anything else. It's not trying to do a lot of work on your behalf. And so looking at our application now, you'll see I access it and I get a login page. And this is the default login page provided by Spring Security. It's a little nicer looking than the old one. We added some CSS that requests an external resource. Obviously, that external resource is cached. But if you don't have network connection, then it'll just be straight HTML. But we tried to make it a little prettier. And then you can also go ahead and type in a username. And then the password is just like you've come to expect with Spring Boot. As soon as you add the dependency to your class path, you get a random generated password. We can go ahead and add that. And we're logged in. And the rest of our application looks pretty familiar. One thing that's a little different with the reactive application, who here is familiar with CrossSite request forgery protection? So as soon as you add the CrossSite request forgery protection, you can't log out because it basically disables that. So if you don't have a login page, we also now, in the reactive support and eventually in the non-reactive support, we generated a logout page too, just to get your getting started experience a little better. Nothing really fancy about that, but we can log out. And the one thing that I'd like to point out, though, that's a little different is that if I tried to do anything that's a post, I get this. I get an error message. And I just want you guys to kind of put that in the back of your minds and realize, that looks like it's broken and we need to solve that. So just remember that for now. But I also want to point out a few other things. So let's take a look at an HTTP request. Earlier you saw we got a redirect to the login page. If you do it from a command line agent, you're getting a 401. What's happening here? Well, the default for Spring Security when you add the enable annotation is it's going to do some content negotiation to try to determine, should I send a 401 because it supports basic auth, or should I do form-based login? So there's some smartness there, and you'll also notice there's no session created. But if I add an accept header, then I get a session. And that's basically saving this, the previous request. So after the redirect is followed, it can send you to the originally requested page. If you authenticate similar, HTTP basic is going to not create a session, whereas form-based login is. The WebFlex security is a lot smarter about when it creates a session and when it does not. And this will come into play when we add the OAuth support so that you can have some more intelligent decisions on what happens when and being able to support the same thing in the same HTTP security instance rather than having to keep multiple HTTP security instances like Madura was talking about, or she referred to it as Web Security Configure Adapter, which is the object that creates the HTTP security. So both are the same thing, really. Excuse me. So going back to our thought about the failed cross-site request forgery, let's take a look and see how we can fix that and why that is actually not working. So we're going to go ahead and create some security controller advice. And we're going to take a look at that. So this security controller advice is basically getting a server web exchange. So first of all, who here is familiar with controller advice? Okay, most people. Controller advice is basically going to be invoked on every PC request. And what's happening is the server web exchange is being passed in as a method parameter, and we get an attribute from there. And that happens to be a mono of CrossSite request forgery token. And in Reactor, if you don't subscribe to that mono, it's kind of like a promise. If you don't subscribe to it, nothing happens. So it's not saved. It's not going to be actually used. But what we say is, if someone does subscribe here, we're going to go ahead and set the actual value of it as this default CrossSite request forgery attribute name. And that leads us to a request data value processor. And this processor is how we get the extra hidden fields. So I'm using timeleaf, and timeleaf basically will use this value to look up the hidden fields. And why do I have to do this extra step is probably what's going through your minds. Well, the thing is, with a view, you need to resolve the model attributes that are reactive first, because the view can't really do that very readily. We're looking to provide some improvements to this, hopefully, but at the moment, the contract really is, if you have something that's reactive, you need to resolve it ahead of time for the view. And an easy way to do this is with this little bit of code. And the reason for that is we can't resolve a mono because this is a map, and the timeleaf or other view technologies really can't readily use something that's a reactive mono or other types of reactive APIs. So that's basically the gist of it. And the other thing that we see here is a current user. So back in the day, you used to be able to access the current HTTP request, and you just say, give me the principal on that request, and then you'd have access to the user. Well, again, the user is a principal, a mono of principal that is on that server web exchange. And so you need to resolve it ahead of time if you want to display it in your views. So taking a look at our layout, which is a timeleaf, you can see I have just can you see that in the back? Is that better? Getting nodding heads, so I'm assuming so. So the current user, if the current user is null, then we go ahead and display the sign-up page. Otherwise, we're going to display a drop-down menu with the current user's name. So now we'll go ahead and, I can't remember if we restarted or not. So it doesn't look like we have. So we'll go ahead and restart it. And we need to get that password because we still haven't modified that either. And now we'll go ahead and log in. And you'll see now on the upper right I have user. I guess if you do that, it goes away. But you get user in the upper right, and then I can log out. And the logout works similar to the delete would work as well. So we've basically resolved how we're going to resolve the token and how we're going to resolve the principal. The gist is you have to resolve all your reactive attributes ahead of time before it gets to your view. So now the question becomes, it's kind of annoying to get that password every time from the console. So how do I customize the password? And the way to do that is to create your own security configuration. So we'll go ahead and do that. Create a security config and make it a configuration. I feel like that's not big enough either. That looks better. Can you guys see that in the back? Okay. So we have a security config, and we need to customize it. And it used to be in boot, you used to be able to provide a property that would override the password, but you can't do that as of now, as a milestone 7, I believe we're on. But it should be supported either in the next milestone or release candidate. I cannot recall which. But for now, you're going to have to provide some configuration. And even if in the future, you're going to probably want to provide custom authentication anyways, so it's not going to buy you a heck of a lot. to just use that property in most instances. So we're going to go ahead and start like this and use a map reactive user detail service. So this is kind of the in-memory user detail service. And we're going to see how this fails, and we're going to talk about why very briefly, and then we'll revisit it a little more in detail shortly. So this is going to start up just fine. At least it should. And then we're going to go ahead and try to log in with Rob, and we're going to type the password as password. And you see it says there is no password encoder map for ID null. And this is a big change in Spring Security reactive and the non-reactive stuff. The default password encoder used to be, if you don't provide one, use a no-op password encoder. One of the stories of Spring Security 5 is better password storage, modernized password storage. That's why we kind of went through that spiel at the beginning. So plain text we know is bad. It's Spring Security 5. Let's go to a more modern storage of passwords. And so this password encoder that we're needing is requiring this identifier. And the easiest way you can solve this problem is not necessarily the right answer, but we're gonna take this in stride and do some workarounds for now. We're gonna go ahead and do a password encoder as a bean. And we're going to do the no-op password encoder. So this basically reverts it back to the behavior that we're familiar with of not requiring a password to be encoded. So if you see that error message, that's the easiest way to get back to the regular behavior, but it's not the proper way. We'll revisit the proper way in a little bit. So now when I try to log in, I should be able to log in with Rob, and my error goes away. So hopefully that gives you an idea of how to get past that error, at least momentarily. And if you're upgrading from the non-reactive to the reactive, or sorry, from Spring 4 2x to Spring 5, even in the non-reactive, you see that error message? Easiest way is declare it as a bean, schedule as a separate story from the upgrade itself to deal with your password management. That way you can kind of do things iteratively. You can't do everything all at once. All right, great. So moving on. We've seen how we could do a custom password. Let's take a look at how we can do a custom login page. And I mentioned earlier that all Spring Boot is doing is adding an enable WebFlux security annotation. And you can see it's importing WebFlux security configuration. So we're going to go ahead and open up that. And we got to do the right one here. And this is basically the default that's being used that I have highlighted there. And what I can do now is I can just create a bean and paste that in. And because I can't stand the formatting that gets in there, I'll have to adjust it a little bit, but it's not going to hurt anything other than my eyes. And then we're going to add a login page. So if you don't have a login page provided, Spring Security generates one all by itself. Here we're providing a login page, just like the non-reactive stuff. And then we have path matchers. So path matchers is kind of like AMP matchers, but it's the reactive equivalent. It's using a different strategy for matching the path, but it's the same one that Spring WebFlux does. And we say that we want to match on login and let's see, the sign up page. And we're going to do the web jars. So web jars is all our CSS. Permit all. So once we've done that, we can restart. And while that's restarting, we'll take a look at our login controller that I already created. All this is doing is saying, if you hit the login URL, go to the login view. And the login view is pretty simple. It's just a login form, just like the non-reactive bits. We saw lots of hands for Spring Security, so you're probably familiar with this. It's basically submit a post to the login endpoint and provide a username and password. And this will also include the CrossSite request forgery token automatically due to the updates that we did for the advice, controller advice. All right, so now we're going to go ahead and log in. And you'll see that I have a custom login page, which is not much different than what we saw before, but my UI is consistent. I have a sign-up page at the top, and I'm able to go ahead and authenticate and then I can log out just like we were able to either. Nothing super fancy here, but shows you how to get moving, and it also shows you how to find those defaults. If you forget what they are, you can just look it up by looking at the enable annotation. Moving on, we're going to see how we can do a custom user. So earlier we saw that we had this user's endpoint, and the user's endpoint had a whole bunch of users on it, and yet I'm providing this in-memory authentication. So how can we make this so it's using my actual users that I already have in my system? Well, the first step that we want to do is we want to go to our security config, and we're going to go ahead and we're going to delete this definition here. And the other thing that we're going to do while we're here is we're going to change this password encoder to standard password encoder. And this is because the users that I have in my system right now are already using SHA-256. You'll notice there's a line through it because it's deprecated. We'll improve on this in a little bit. But this is going to show us how we can migrate our passwords from an old storage system where we can't guess what the passwords are to a new storage system. So right now we're storing it in SHA-256. How can we eventually get to something that's more secure is what we will explore in a little bit. But for now, we're just going to kind of do this progressively and live with the fact that this is deprecated. We're going to go ahead and insert here a repository reactive user detail service. And this repository reactive user detail service should look fairly familiar. It's just a user detail service that's returning a mono of user details. And we're looking up that mono of user details using an existing API that we already had of user repository using Spring Data. And then we just map it to our custom user details. So one of the things that I like to emphasize in security, particularly when using Spring Security, but any security actually, is you should not use the framework's representation of the user throughout your entire code base. No different than you should. You don't want to be coupled to it, right? So what am I doing here? I have this custom user details, and it extends user. A user is this application's domain object. And why is that important? Well, Spring Security doesn't have a representation for everything you need about a user. Think about it. If we added a first name and a last name, some people would be happy if we added that to the user, but other people would be mad. If we added an address or car or anything like that, some people would be happy, some would be mad. So we have on our domain object just what we need to make authorization decisions, right? Authentication, authorization, that's what we focus on. But you guys have your own business logic that you need to focus on. And so what you can do is you can extend your object, or if you have an interface, you could implement it as well, and implement user details. So this object is both user details and your user object. So when you're resolving the user, you can refer to it as your user object, and Spring Security can refer to it as a user details. And you don't have to worry about the fact that it's a Spring Security object throughout your entire code base. So if you remove Spring Security someday, you're still using all the same code throughout the rest of your code base. So now that we've done that, we should be able to go ahead and restart our application. And now we'll go ahead and try to authenticate as Rob. And we're able to do so. But now we should also be able to authenticate as Joe. And we also have Veteran in here. So Veteran is going to be working on Spring Security starting in January. He's going to be new to the Spring Security team. There we go. And you'll notice the inbox is the exact same for all these users, which is not accurate. And the reason for that is because we've got a hard-coded constant. But we are able to log in with all these users. The thing is, though, if we tried to sign up as a user, and then we try to authenticate as that user, oops, we get this strange error. And the reason for that is when we're signing up for the user, we were assuming the default no-op password encoder when we created that user. So we're going to have to correct that in a little bit. But that is broken at the moment. So let's go ahead and explore how to fix our inbox real quick. So we looked at the inbox, and we saw that in our inbox we have basically all the same messages for every user, which is not accurate. So how can we solve that? Well, just like you could in, excuse me, just as you could in the non-reactive world, you can in the reactive world add an authentication principal and the user, and then you have that user. And now we can also say user.getID. So now we're getting all the messages that are to this particular user that's logged in. So we've resolved that. Another thing we might want to do is, for our security controller advice, we might want to go ahead and change we might want to change this as well so that we can, instead of displaying the username, maybe say we want to return the user's first name in the UI. So we can do that. And now we need to go ahead and update our layout. And if we restart, we should be able to log in as Rob. And now we see an inbox with population, that's populated, and Rob is in the upper hand corner. So this goes back to show you might need custom attributes. This is how you access them. The ID is custom, and the username, the first name is custom on my representation of the user. And I don't refer to Spring Security throughout my entire code base, only in the Spring Security specific places. And then I'm able to log out. Now I can log in as a veteran. Veteran's inbox is empty. And my UI is incredible, so it doesn't give a message. It just mysteriously displays nothing. But the idea is that now you can access these custom properties from your custom user. And we need to figure out, though, how we can get our sign up to work and see, how easy that is. So we already exposed that standard password, the standard password encoder as a bean. We're going to go to our sign up controller. And we're going to go ahead and add a password encoder to this. And now we've added the encoder, but now we need to use that. So one of the things that I talked about earlier is encoding passwords can be costly. So we probably want to do this. We will probably want to do this on a separate thread. So we can basically say, since this is based upon the CPUs, we can use this. Oops. Subscribe on. We're going to subscribe on the scheduler's parallel, which is if you're bound by CPU. And then we're going to do on next the user. We're going to change the user's password to be the encoded password. Or at least we're going to try to. Let's see. There we go. So now that we've done that, we're going to go ahead and restart. And now if we sign up, we can go ahead and try to log in as this user now. And it should be encoded. So we can log in, and this user also has no messages. So now we solved the sign up issue. We can sign up a new user. We are using our users in the systems. But what about that deprecated password encoder? How can we handle that? Let's go back to our security config. And let's go ahead and change this to be password encoder factories. Create delegating password encoder. So this password encoder is the default, but we're going to explicitly declare it as a bean. And how does that work, actually? Well, it's basically creating a whole bunch of delegates for the delegating password encoder. And we're going to go ahead and take a quick look at this Java doc. The idea is that you can have an identifier, and it maps to any implementation of a password encoder. And how do we create it? Well, it's just a map that's injected into the delegating password encoder, and then one of those IDs is selected for encoding. So any of the password encoders, depending on the ID, are going to be used for validating the password, but only one of them, the most modern or preferred one, is going to be used for encoding. And if that changes in the future, because remember earlier we said things change throughout time, we have to decide what the best one is. Spring Security can't change too often. So we have this delegating one that can do any sort of password encoding based upon your configuration. So we have a very reasonable default, hopefully. And given the format of curly brace ID, curly brace encoded password, we can look up the identifier, and then we can determine which password to delegate to. Now you might say, I already have a modern system. It's using bcrypt, and I have other systems that need to integrate with it, and I don't want this identifier in there. That's fine. Just use bcrypt password encoder as a bean, and the delegating one is out of your way until at some point you need to support multiple, and then you can do the delegating password encoder later, after you do like a password migration. So you can support either one, but this is our default because it supports password upgrades in the future. And you might say, well, how can you do password upgrades? Let's take a look at this. So we have an interesting scenario right now because we demonstrated that we have SHA-256 passwords already, but we might have some new users signing up. So let's see how we can make this a little more secure for the users that are signing up. Now we're creating the delegating password encoder. Now, each time on my database startup, I'm using an embedded Mongo, I'm creating new users. And we're going to go ahead and pretend this is my data migration. And what is this doing? You don't really need to look at the details of it, but what it's doing is it's prefixing all the passwords that are in the existing system. This is the migration you would perform to with curly brace, SHA-256 curly brace. So delegating password encoder knows that anything in the system is going to be SHA-256. If you have a different password encoder, you would just provide the correct ID for whatever you're trying to migrate from. All right, so now that we've done that, let's go ahead and see what happens if I restart my application and try to log in and view my users and create a new user and see what happens. So I've restarted, and now I'm going to go ahead and log in as Rob. And I can log in no problem. Now I'm going to try to create a new user. And now, well, let's go ahead and log in as that user. So we can log in with all of them. But now let's take a look at our users. So obviously, you wouldn't have a user's endpoint like this if you weren't doing a demo because you wouldn't want to expose the passwords. But this makes it really nice to see what's happening. So our data migration worked. SHA-256 is at the beginning of every password, except for the ones that we just created. The new ones that we created are in bcrypt format. So this is showing how your password storage strategy can evolve. The new users are getting a modern way of storing their passwords, and the old users are still being able to authenticate with the same system. Question?
Can you migrate them as they log in? But whenever anybody logs in, you change them?
The question is, can you migrate them as you log in? And I am so glad you asked that, because we are going to do that next. You'll get your $20 afterwards. Thank you. I'm just kidding. I'm broke. All right, so what we're going to do is we're going to create a password upgrade reactive authentication manager. And what is this really doing? I'm not going to go through all this code, but I'm going to give you a quick summary of what's happening. It's going to try to use the existing authentication manager that we're already using at the moment. And if the user authenticates, then it's going to do a migration on that user. If the user does not authenticate, it doesn't do anything. So that's really the steps that it's using, and it's using the password encoder that we provided as a bean. So that's the gist of what this code is doing. And we're going to go ahead and restart. And now that we've restarted, we will go in to here. And we're going to go ahead and authenticate as Rob. And now that I've authenticated, excuse me, we're going to go ahead and take a screenshot by accident. Okay. Apparently my history is lost. And so we're going to create a request to see our users. And you'll look up here that Rob at example.com is now bcrypt. So you can migrate them as they authenticate. And you might also say, OK, well, these passwords were stored in an invalid, insecure format. You could also send out an email if you have the email address of your users and say, hey, for security purposes, please create a new password. You know, they don't have to, obviously, but if they do, then their password is not only migrated, but the old password hopefully is no longer being used, and it's in a more secure format. So that's probably the final step you want to do. Now, going forward in Spring Security 5, we want to provide better hooks to actually support this sort of workflow in reactive and non-reactive applications more seamlessly. And not only do we want to do it when we want to make it more intelligently. So how could we improve on that? Well, right now we're doing it every time. But if the user's already in bcrypt, should we actually upgrade the password? We probably don't need to. Do you want to? Maybe you do. But we're going to provide now that we're on Java 8, we can provide a default method for a password encoder that basically has a result that not only says, is it a match, but should the password be re-encoded, and maybe a method to re-encode it with a new strategy. So it'll be like a password match result or something like that has a strategy for updating passwords conditionally based upon the interface or based upon the implementation. So that's something to look forward in the future for Spring Security. But for now, you can easily do this sort of strategy. OK, so enough talk about passwords. We've updated how our passwords are being stored, and we're feeling good about the security of our users' passwords. Let's see if we can make some better decisions for authorization. So you'll notice right now I can access users, the user's endpoint, but so can, for example, so can Joe, right? So Joe can also access it, and so can veteran. So how can we change this to have some more restrictive authorization decisions? And we can do that by adding a new authorization rule. This should be no surprise to you guys, because it's very similar to the standard non-reactive support. But you can add something that looks like users. And you could say has role admin. But right now, we've hard-coded all of the users to be a user, so we don't have a role. So maybe we could get a little more creative. Maybe we could use access. And then maybe we could say is Rob. So this is something that's a little different from the non-reactive support. You could use spell in the non-reactive support, but you can't use a method. And here we can just actually have a method that looks like the reactive authorization manager. And the reactive authorization manager just has this signature. And now I can just say, we can say, first we're going to map it to the authentication, the username, and then we're going to map the username to starts with Rob at, so if it looks like Rob, and then we're going to map that to an authorization decision. Now if I restart this application, if Joe tries to access it, he gets forbidden. And then if Rob tries to access it, he is allowed access. So it's a very easy way. You can basically just use method reference, or you could obviously implement the interface if you want. Either way is perfectly acceptable. If you have roles, you can do that. It's very similar to the non-reactive support, except you have, rather than spell, you're using a method reference. And we may be adding method references to the non-reactive support as well going forward, but just due to time constraints, we're kind of sitting on this and seeing how the community likes it. So another thing that we might like to do is if you go into here and we log in with as a stale page. So I'd restarted my server, and so the token wasn't proper. So if I log in as veteran, for example, he has nothing in his inbox. But the thing about veteran is he's very clever, and he knows that if he accesses the messages directly, he can access the messages. So what can we do to solve this problem? Well, we could add this similar expression that we did earlier to the URL, or we could do method security. And since we've already done the URL-based security, we're just going to do method security. In reality, you probably want to do both to have defense in depth, but we're going to just explore the, method security. So how do we go about adding method security in Spring Security Reactive? Well, we can go ahead and go up to the top here and add an enable annotation, reactive method security. And then we're going to go to our message repository. And we add a post authorize. Should look very familiar if you've used the non-reactive support. And we'll go over this in just a second, but we're going to say that if the message is to the currently logged in user, then we'll allow access. So how's this working? Return object is basically the object that's being returned. But in reactive applications, you can't really, it's kind of difficult to deal with the mono. So what we do here is we resolve the mono for you in the aspect that we add. So the return object is actually not the mono, but the message of the mono. If it's a flux, then it's each individual object within that flux. And then you can say to, so the message has a property called to that is a user, and that user has an ID. And then if that's equal to the currently logged in user, then we'll allow access. And let's see, we're going to go ahead and restart while. So you might say, OK, well, the principal, why does it have that ID property on it? Well, we talked about that earlier when we looked at the inbox. We allowed the inbox to be customized based upon the currently logged in user using authenticated principal. Well, we can do the exact same thing here with our spell expression. Principal happens to be a user from our domain, which has an ID property on it, first name, last name, et cetera. But it also happens to be a user details. So it has both properties on it. Now that we've restarted our application, we're going to go ahead and try to re-log in. And we're just going to log in as veteran. And you'll see that he doesn't have any messages. And then now access is denied. And you might say, well, how is this working? How in a reactive application am I accessing this user context? In Spring Security, the source of truth for a reactive application is reactor context. And the way that works is when you build your reactive pipeline, you just state the context and provide the user, and then each of the subscribers has that context. We aren't going to go into detail how that works, but Project Reactor's documentation has some very good examples of how the context works, and it'll outline that in more detail. But for now, just know that it's basically added to the subscribers, and it works. Oh, Thank you.
Welcome. Oh, your team says that comes with a cert attached to it.
So that's basically how it's working. Now, let's see here. We are going to go ahead and try to do some methods, go ahead and do some tests real quick. So we have some tests already written, and these are going to fail. So these are using Spring Boots. We're auto-wiring the web test client. We saw that already in the keynote. And these tests are going to fail. One of them passes, actually, but the others fail. And the reason for that is they need to be authenticated. So what can we do to authenticate our user? Well, for this one, we can say with mock user. And then this one says that it needs to be with Rob. So we'll do with mock user, Rob at example. And then we're going to go ahead and rerun our test. Now, one of them is going to pass, one of them is going to fail. Well, two of them will pass, one of them will fail. And the reason for that is earlier we said on our controller advice, resolve the currently authenticated user's principal. And we're using a mock user object, which is not our custom user object that we needed in order to resolve our ID and our first name, right? So it's not going to work. So how can we fix this to work? Well, just like you can with the non-reactive support, you can create your own custom annotations that work with Spring Security's test support. So let's see how we can do that. We're going to go ahead and add a with mock custom user class. And then we're also going to add a with mock custom user factory. And we'll go over these in just a second. And then we're going to add with Rob. So what are these actually doing? So with mock custom user is basically an annotation that allows me to specify, I want to use my custom user that we saw in our user details in my tests. And how does it know how to create that? Well, it uses this annotation to declare it. And then this factory is used to create it. Spring Security's test support sees that annotation with this factory. We'll use this factory, which provides the annotation. And then we just go ahead and create that user and populate the security context. Once that context is populated, Spring Security's test support properly provides that in your test support. And how does it do it in a reactive application? It populates the reactor context that we talked about earlier. So that's how it's being populated. Excuse me, a little bit of a cold. And you might say, well, I could just use this with custom user, but it's nice to have different personas. A lot of times whenever you're defining user stories, you have these personas, and you have with Rob or with Joe or with veteran or whatever your personas might be. And rather than having to redeclare Rob at example.com every time, you might just have with Rob. And then that way it's a little easier to read. It follows your user stories. And it's easier to not get typos for someone that might accidentally type the wrong username or something like that. So now let's modify our tests. So now we can say with mock custom user. You could make a different persona for that test as well if you wanted, but we aren't going to do that. And then we're going to do with Rob. And now we'll go ahead and rerun our tests. And our tests should pass. And they all pass. So now you've seen how you can also test your security within reactive applications. It's very similar to the non-reactive support. And the big difference is you're integrating with web test client rather than the mock MVC client. So it's a little different there, but otherwise it's very similar. And this support also works with your method security. So if you're using method security, it's going to automatically add the proper user to the reactor context, and then your methods will get invoked properly as well. And you can see that actually already because we're invoking the user's endpoint, which we added method security to. So with that said, I have about 5 minutes for questions. I'd love to hear any questions if anyone has them. Yes, please. So the question is that they have basically an algorithm and then the password on separate database columns. And the question is, can Spring Security support it in a separate column from the password or a separate property? Excuse me. And the answer is no. And the reason for that is the API only allows a password, not an algorithm. So all the information is provided in the password. Similar to how password encoder has the salt embedded into the password, the algorithm also needs to be embedded into it. Now, how could you support that? You could basically do a migration for each password, copy from this column over to the other column, concatenate them, and then that would work. So that'd be how you do it. Or the alternative is you would just need to provide more hooks within Spring Security rather than using a reactive user detail service. You would need to basically provide a custom authentication manager, which would look up both properties separately and then look up the password encoder separately. So you could do it that way as well. Does that answer your question? Awesome. Any other questions? Yes?
You would like to implement your own pre-out filter. Will there be any difference from the standard security?
I believe the question was, if you'd like to implement your own pre-auth filter, is there any differences from the standard security? And the answer is yes, because standard security uses a servlet filter, and reactive security uses a web filter. So one's a reactive API and one's a non-reactive API. The other difference, too, is in Spring Security, we actually have, in Spring Security's reactive support, we have authentication web filter, which is used for basic auth and form-based login. It's the only authentication filter that we have at the moment. And you might say, well, how's that working? Well, it basically has different strategies on how to resolve the authentication. So there's a strategy to say, get from the request, convert to something to authenticate. And then there's another strategy that says, after I log in, what should I do? Should I do a redirect? Or should I maybe do a save and then a redirect? So I save the request and then a redirect. That's how the form login is working. Or basic is just continue the filter chain. So basically the gist is you switch over to a new interface that's reactive, and then you would use this authentication web filter, and you create something that extracts the principal from the request and provides that on the chain. Does that answer your question? So the question is, if you move to reactive, the previous filter will not be supported? Is that the question? Yeah, and the answer is yes. The previous filter is not going to be supported because it's not a reactive API. You cannot use a servlet filter in the Webflux support for Spring. It's not compatible. I believe this gentleman's had his hand raised. I will come back to you in just a minute. Yes. So the question is, when you're doing the authorization in here, there's an authorization context. Let's see, this authorization context. So this authorization context has access to, apparently I did the wrong one. It has access to different things. So one of the things it has access to is the web server exchange, right? So the exchange that is basically being authorized. So whatever you're trying to authorize is one of the things it has access to. But it might also have other things like variables. So the variables might be declared if you had a URL that looks something like this. ID is now one of the variables in that authorization context, so you could actually make an authorization decision based upon the URL. And what those variables are might be dependent on the context. So in this context, it's a URL path variable, but in a method security, it might be method arguments. Does that make sense? Good question. And I believe I said I'd come back here.
You can still use the non-reactive parts
So the question is, you can still use, can you still use the non-reactive? Yeah, servlet filters with reactive security, and the answer is no. Oh, if you're not using reactive support? Correct. So, okay, so the question is, if you're not going to do reactive support, can you still use the old filters? And the answer is yes. Those will still be around. Sorry, I misunderstood the question. Yeah, the question earlier was that as well, apparently. So if you're sticking with a non-reactive application, can you still use the old filters? And the answer is yes. Thank you for clarifying. Any other questions? All right, well, thank you very much. Oh, we got one more question. Yes, my code is actually already available. It's on GitHub under the handle rwinch. And I'm not sure how we're distributing the code, but I'll make sure that the conference has that available for you guys as well. And if you follow me on Twitter, I'll go ahead and tweet it out as well. I'm going to go ahead and wrap up so everyone can head out. But if you have more questions, feel free to come on up and ask me. Thank you very much for your time.